was for experiments with entangled photons, establishing the violation of Bell inequalities, and pioneering quantum information science. Scientific American ran the headline, "The universe is not locally real," and the physics Nobel Prize winners proved it. Hopefully this far in, you guys see that that's not flowery language. That's the conclusion of the most rigorous experimental physics of the last 50 years. The universe is not locally real. But what does that actually mean? Well, it means Einstein was wrong. Particles do not carry hidden predetermined instructions. There is no pre-written scripts that makes it possible for distant objects to appear to be causally affecting one another. Instead, objects do not have definite properties before they're measured. And entangled particles, no matter how far apart they are not two separate things that happen to behave similarly. They're one system. Measuring one instantaneously determines causally the state of the other, not because a signal traveled between them, but because they were never truly separate objects to begin with. As we were talking about before, the distance between them is just a representation on the screen. Underneath, the system has access to everything at once. It's all connected. There's no actual separation. There's no true locality. It's not real. The problem is, they're both wrong. Ultimately, it was developing my first video game that made all of this click for me and convinced me that we probably are living inside of a simulation. I have the chills now. That is so crazy. Here's exactly what game dev teaches you. When you build a game world, you have to make a fundamental decision about how that world exists. Do objects exist permanently, fully rendered, fully real, fully tracked all the time, whether or not a player is anywhere near them? Or do you only render and resolve what's actually being observed by the player in that moment? Now, every serious game engine chooses the second option because the first option is computationally catastrophic. You cannot maintain full, permanent object states for an entire world simultaneously without melting your computer. The processing cost would be insane, truly, on a level that we cannot comprehend. So instead, you build a system where objects outside of the player's view exist only as potential, as a probability set, as data that's waiting to be processed, but ultimately it's just code. The moment a player needs to see or interact with that object, then the system runs the code, which is full of math, and the object gets resolved into something definite, something real. Remember that scene in The Matrix where the kid says, "You only need to realize the truth, that there is no spoon"? That's exactly what we're talking about here. What we look at is just the display. It's not what's really happening. What's really happening is computation and math. Underneath the visual layer of the game, the system has access to all of the rules and the information simultaneously, regardless of how far apart the objects on the screen are. It's all being processed in the same space. The staggering vastness of a video game world is actually entirely contained inside of a computer that can sit on your lap. Two objects inside of a game that seem incredibly distant from one another are actually in the same space computationally. They may appear to be on opposite sides of the universe from inside the game, but in actuality, they're just data structures sitting next to each other in memory, getting processed by the same chips and governed by the same system. The illusion of distance is just that, an illusion, which means there's no true locality in a game engine. There can't be. Locality is simply something you deliberately simulate to make the world feel believable. Now, realism, objects having definite permanent states, is simply something you have to fake because true permanence is far too computationally expensive to maintain. Now, the Nobel Prize in Physics was just awarded for proving that our universe is designed the exact same way a video game is. To understand how we know this to be true, let's look at the experiments that earned the Nobel Prize. The odds that you're living in a simulation border on 100%, meaning this, all of this, is almost certainly not real. In October of 2022, the Nobel Prize in Physics was awarded for proving that the universe renders like a video game. The technical phrase is that the universe is not locally real. The existence of an object and its position and movement are merely a set of probabilities until something in the system observes or interacts with them. Not only does that discovery increase the odds that we're video game characters living in a simulation, it proves that Albert Einstein was wrong. And not about a minor detail, about the fundamental nature of reality itself. Einstein spent the last 30 years of his life insisting that the universe had to be locally real, that objects exist independently. They're out there, in the world, knowably. Our intuitions tell us that he must be right, that nothing can influence something else telepathically across vast distances instantaneously. But experimental evidence proves that what Einstein called spooky action at a distance actually is true. In the 1970s, physicist John Archibald Wheeler proposed a brilliant variation of the double slit experiment called the delayed choice experiment. It was a very difficult experiment to run, so it took decades for someone to pull it off. But once they did, it turned everything upside down. Wheeler asked a simple question. What if you don't decide whether to turn on the detector until after the particle has already passed through the slits? Think about what that's actually asking. The particle has already made its journey. It has already gone through the barrier. It has chosen one slit or the other. Whatever it did, wave or particle, it has already done it. Now, after the fact, you decide whether you were watching or not. Does it matter? The crazy thing is it does. In 2007, physicists at the Institut d'Optique in France ran this experiment with the precision required to actually test it. The result was unambiguous. When the researchers turned on the detector, after the particle had already passed through the slits, it retroactively behaved like a particle when passing through the slits. When they chose not to observe it, it retroactively behaved like a wave when passing through the slits. The decision made after the fact determined what the particle had done before the fact. The present detection somehow reached back in time and changed the past. As soon as they set up the detectors, the interference pattern completely disappeared. For whatever weird reason, the moment the system captured information about the particle's path, the particle stopped behaving like a wave and started behaving like an individual particle. Two clean bands. No interference. It's as if the particles knew they were being watched and suddenly decided to act differently. It's like the toys in Toy Story act like lifeless toys when humans are around, but then jump up and prove themselves to be truly alive when the humans are gone. When researchers turn the detector off, the interference pattern of the wave comes roaring back. Turn the detector back on, the interference pattern disappears again. This has been replicated thousands of times in labs all over the world. The result is always the same. What's even crazier is that the particle doesn't need a conscious human observer to collapse into a definite state. It doesn't need eyes or awareness or intention. It just needs any physical interaction that captures information about the particle's path. A detector, a stray photon, anything that records which way it went by measurement or interaction. The moment that information exists anywhere in the system, the wave collapses. It becomes specific. The particle commits. It gets fully rendered into reality as something specific and not just a wave of probabilities. The universe isn't responding to consciousness like a game engine. It's responding to information processing.